Hello and welcome to another video of Science and Tech at UPSCprep.com. My name is Ishan and I'll be taking you through the current affairs of various topics over the course of the next set of videos. So, for this particular session, we'll be looking at space technology and biotechnology. I'm trying to cover everything till February or around March, right? And whatever is left, we can maybe cover that later on. Right, so let's start. Let's start quickly, and let's move on to the first set of topics that we have to do. These are Indian missions that have been in news. Right now, there are other missions that I have covered in previous videos. These are the missions that I have not covered. So I'll be looking at these in particular. If you want to have a look at other things that have been in news, you can watch my previous videos. Right. So in space technology, if you look at the Indian missions, there has been Spadex. There has been talk about Bhartiya antariksh station. Then there have been, words going on around Venus orbiter mission. Now, this has been in news for a lot of years, but now it has finally been approved. Right now, then there's an Astrosat which has found out something new, so that's why um, it was seen back in news. So let's have a quick look at each of these topics, and then we'll have further looks at other things related to space tech that have been in current affairs. All right, so SpadeX is basically the space docking experiment. So if you look at the figure over here, docking basically, if you look at ships are docked at ports, right? So what is the meaning of docking? It's just like you're trying to set up, you're trying to park maybe, right? So you have one object and then another object. You're trying to uh, park them upon one another, right? So you mostly have a chaser and a target, right? So they would be a chaser and there would be a target, right? So you try and dock this chaser to the target. Now, why do you need to do this? Because see, there are so many satellites in outer space. You could need to refuel these satellites. You might want to repair these satellites, or you might want to exchange crew. Now, crew exchange is a crucial part where you need to understand that when you are thinking about moving humans to taking humans to space, uh, right? So there are going to be space stations, right? So I'll be talking about space stations, but there's going to be a satellite which is already going on around Earth. So this is a station, right? Now the astronauts have to reach this station. So they'll be in a separate module. Now this module has to go and dock to this station. Only then can you like open the doors. If you've seen movies, they'll open the doors and they'll move on to the other spacecraft. So that is how it happens. So first docking has to take place, uh, and this docking will mostly help in uh, either if the satellite is damaged, uh, this people in this spacecraft can go and repair or refuel or just change their spacecrafts, right? So this is the basic understanding of what docking is. India becomes the fourth country to achieve successful space docking after US, Russia, and China, and ISRO had launched Spadex via PSLV C-60. All right, so that was the mission. What is space docking? It's just like you're connecting two spacecrafts. It could be manned, they could be unmanned, but the objectives could be refueling, it could be repair, it could be just exchange of crews, right? So uh, maybe if two astronauts are going from here to here, the two other one who are there, they will come back and they might want to come back to Earth. All these things, they have to uh, be achieved. So docking is the first step, right? So docking has to be demonstrated. So ISRO has successfully demonstrated. Now I was talking to a scientist uh, in ISRO of I think a month ago, and they told me how difficult this mission was because initially when they tried to do it, even when the docking successfully happened, the electricity exchange did not take place. So there are a lot of technical aspects also attached to it. Might not be able to discuss it in this session, but there are so many technical aspects. Two spacecrafts have to dock, and every part has to match perfectly. And then power exchange also has to take place because then without power, what will you do? Right. So that is the understanding of docking. Now, docking is a term which is slightly different from another term, which is called berthing. So, docking is a process which happens autonomously, which means it is automatic, right? But in berthing, there is going to be a robotic arm. So, the difference here, just remember, whenever they were talking about berthing, in berthing, a robotic arm is first going to attach to the other spacecraft, and then you need, you will be performing uh, the the docking. Okay, right. So that is the understanding, and uh, docking means spacecraft attaches autonomously. Berthing means there's first going to be a robotic arm that is going to attach, and then you will be uh, combining those two spacecrafts. Okay, connecting those two spacecrafts. All right. So the mission Spadex was about mastering autonomous docking. That we have understood. There was a chaser and there was a target at 700-kilometer altitude, and then they demonstrated successful space docking. Right, so that is all about SpaceX. Let's move on to the next one, which is Bhartiya Antariksh Station. Now, the cabinet has approved this first unit of Bhartiya Antariksh Station under the expanded Gaganyaan program. Gaganyaan, if you remember, is the human spaceflight program of ISRO. Now, what Union Cabinet has done is that they have tried to expand this program to a more comprehensive one, looking at the long-term goals of our space department. So what is the long-term goal? The long-term goal is to not only take humans to space, but to take humans further onto the moon. So you've had three Chandrayaan missions. Chandrayaan 3 was the latest, and you'll have Chandrayaan 4 also, Chandrayaan 5 also coming up over the next 2 decades. And within the next 2 decades, it will be around 10, 15 years, we'll see those missions. Right. So by 2040, what do you want is you want to land an Indian on the moon. That's what you want to do. That's what ISRO wants to do on its own. And for that, first you have to demonstrate that they can go to space on their own. So for that, they have Gaganyaan program. Under the Gaganyaan program also, they are saying that we will also construct a space station, which is going to be called as the Bhartiya Antariksh Station. So by 2028, they're going to launch the first module of this, and it's going to be mostly operational by the year around 2035. So these are long-term plans, but yes, very, very relevant considering that India is also going to be one of those countries which is going to have this capability, right? So by 2026, there will be 4 Gaganyaan missions under the current program, right? So this will go on as it is right for now. And there's one more thing that has been approved, which is the next generation launch vehicle. Now, next generation launch vehicle is going to be much stronger than the already present vehicle called LVM-3, right? So GSLV Mark 3, earlier it was called GSLV Mark 3, now it is called as Launch Vehicle Mark 3. And when you look at the next generation launch vehicle, which has been approved, now next generation launch vehicle is going to have 3 times the payload capacity of Launch Vehicle Mark 3, right? So it will carry around 30 tons to Leo. So yes, that's also going to be one of the objectives. Right. So, why do you want to construct a space station or an Indian space station? First of all, always remember that space stations are made in Leo, and for Bharti Antariksh Station, the range is going to be around 400 to 450 kilometers. The objectives could be, you want to demonstrate that you want to demonstrate humans space flight capability for your country, right? Then there could be uh, experiments, space experiments, right? There could be experiments on technology, it could be on your body, what the impact on your body is, right? So, and then it could be used as a base for future missions, right? So tomorrow, if you want to go to moon, um, you already know how to make a space station, right? So, uh, what can happen is that you can go and have a break at the space station, and from the space station again you can go further on to the moon, right? So this is how it is going to pan out. uh, Now, another thing is that most of the countries have already made their own space stations. If I take the example of Russia, which built Salyut long back, Salyut, yes, then NASA, which built Skylab, right? Then the most known one is the International Space Station, which is a collaboration of various countries. There is US, there is Japan, there is Russia. Now Russia is not there. And there is Canada, right? There is European Space Agency, and all of them have come together to make the International Space Station. All right. So uh, this is the understanding, and based on this, India is also going to make its own space station. There is China, which has Tiangong as its space station. Then, if you have any idea about NASA's Artemis missions, which are the moon missions, right? So there are a set of moon missions, Artemis 1, 2, 3, 4, 5, right? So they also have a target of a space station, but now they have the goal of a space station around the moon, right? So they are going to create this. If this is Earth, this is Moon. They are planning to make a space station over here around moon, that will be called as around something called as gateway, right? Gateway to the moon. So no, this is the development that is taking place in terms of space stations, and I hope you have understood what it means. Station just means a place where you go and stay, right? So um, uh, India is planning on making its own space station. It will be called as Bhartiya Antariksh Station. There will be several steps. There will be Gaganyaan missions by 2026. There will be first module by 2028. By 2035, they'll make it operational. By 2040, they are planning to land on moon. Right. Then there is next gen launch vehicle, which is in the plan. Right. And there's going to be several objectives. Right. We have discussed. Okay, so let's move on to the next topic, which is Venus orbiter mission. Now, this is another mission of ISRO, very ambitious mission. We're going to study Venus. Right, here you're trying to study Venus. Uh, it's the maiden Venus mission. Right, so it is going to be the maiden Venus mission, but the second interplanetary mission. So we've already been to Mars. We have a Mars orbiter. So now you're going to orbit around Venus, right? And why do you want to study Venus? First of all, let's look at why are we actually going to Venus? Because Venus is very similar to Earth. It's called as the Earth's twin planet, right? So it's very much similar in shape and size, right? And it has a runaway greenhouse effect, which means that it has a lot of greenhouse effect. The temperature goes up uh, to great degrees. So one of the reasons is that you will also like to study, look at something of the greenhouse effect. It has thick toxic clouds. There is extreme heat, and there is possible microbial life. Because of detection of phosphine, they have guessed that there might be microbial life. And at one point of time, Venus was thought to have water as well. Now it is just dusty and hot and dusty. But at one point of time, they used to feel that Venus has water. Okay. One of the special features is that it rotates from east to west. Most of the planets they rotate from west to east, but Venus rotates from east to west. That's also something that they would like to have a look at. Right. So the objective of the mission will be to study Venusian dust, air glow, surface topography, solar X-ray spectrum, subsurface characteristics. Right. And you will demonstrate aerobraking, which means that it's 64 million kilometers away. So obviously, spacecraft will be flying at great speed. So we'll try and uh, do some aerobraking to um, make it revolve around uh, Venus, and then thermal management because of high temperatures. You'll also be managing the spacecraft will also have to manage high temperatures, right? So these are the goals of Venus orbiter mission, right? So that's what you're going to do. I hope you understand what is the meaning of topography related to the relief features, X-ray spectrum. I hope you understand they're trying to study various elemental compositions, right? Subsurface characteristics, again, they're trying to do some kind of spectroscopy to understand what is there inside the surface. All right, so this is the objective of Venus orbiter mission. All right, and it's going to be launched in uh, March 2028 via LVM-3. Right, so that is going to be the way about it. Let's move on to the next one, which is Astrosat. Now, Astrosat recently discovered an irregular X-ray emission from a black hole binary star. Now, Astrosat is nothing new. It was launched in 2015 via PSLV C30, and it was placed in Leo. All right, it was placed in Leo, and it is India's first multi-wavelength, because it is studying celestial objects in three wavelengths: X-ray, visible light, and UV light. Studying elements and celestial objects in space in three wavelengths. That is why it is a multi-wavelength space observatory. Observatory means that's observing things in outer space. So one of the things that it has observed lately is the irregular X-ray emissions from black hole binaries. So black hole binaries, again, it's just a couple of black holes together, right? So that is simply put. And if you look at the objectives of Astrosat, what is the objective? They are already going to they're already studying high energy processes in binary stars. They are detecting new transient means very lasting for a very short time, transient X-ray sources, investigating star birth regions, right? So these are the most of the objectives, and they are using 5 payloads, which are mentioned over here. You don't need to learn all the names, but just need to know something about what is Astrosat, what does it do, what is the objective, and what is the recent discovery that it has made. Okay, so that is all about Astrosat. Um, okay, that is all about Astrosat. Just remember, always remember the orbits of any satellite that you study, any Indian mission. Uh, please do not forget the orbit. Which orbit is it actually placed in? All right, so that is all about Astrosat. So now let's have a look at some other topics which are not specifically related to ISRO, but they are nonetheless important from the point of view of your syllabus, and they have been in news in the past few months. All right, so let's get started on the other topics. First is Lignosat. Now, Lignosat is the world's first wooden satellite. It was developed by Kyoto University and Sumitomo Forestry Institute. Now, it was made from magnolia wood. Now, why are you making a wooden satellite? Obviously, when you're choosing the wood for this, you will always be choosing something which is more strong, is more durable. But why wood? Because what you want is you want an eco-friendly satellite, which means that this will not create any space debris when it is going to come down. It is going to burn completely on re-entry, leaving no debris. Right. So it's sustainable, it is reducing metal pollution in space, and it is going to test wood's viability in space. And now wood, if you look at wood, it is more durable in outer space because there is no air, there is no water to rot it. So um, it is more durable. It becomes very easy to put wood uh, as a sustainable material for satellites, right? So you can have a look at how this looks like. Now it is going to pave the way for sustainable satellite technology if it is successful, right? So that is the Lignosat mission. All right, so let's move to the next one, which is expansion of the universe. Now, dark energy spectroscopic instrument in US. It has measured something about the expansion rate of the universe, and they found out this to be 68.5 kilometer per second per megaparsec. Now, what is parsec? One parsec is around 3.26 light years. Okay, so one megaparsec is 3.26 million light years. Right, so now this is the unit. How they're measuring is not important, but this is just the unit that they're using for measuring expansion rates of the universe. And then based on this, they have created the largest 3D map of the universe. So now let's look at some theories which are related to expansion of the universe. Of course, the most important one is the Big Bang model, which says that everything started from a hot and dense singularity. There was some singularity. Um, no, which is what just a point, and from that everything originated 13.8 billion years ago, and the universe has been expanding ever since then. Right, so that is one thing, and it is one of the few theories that is able to explain the cosmic background radiation. Right, cosmic background radiation. Right, so light, a cool remnant of light which is traveling freely throughout the universe, that is known as cosmic background radiation, and Big Bang theory is one of the few models which explains this properly. There's one more model called the matter model, cold dark matter model. Right. So what this says is that dark energy, there's something called dark energy, and there's something called dark matter, and then there's something called normal matter. So normal matter is everything that you see around you. But when you go to outer space, now there are there's a theory which says that there is a hypothetical matter which you cannot see, but it exists throughout the space, and it occupies around 27% of the space, and that is called as dark matter. Right. So normal matter is just 5%. Everything that you see around, that is only 5%. 27% is dark matter, and then the remaining is dark energy. So this cold dark matter would say, this CDM model, cold dark matter model would say that dark energy is speeding the expansion of the universe, but dark matter is trying to slow it down along with normal matter. So it's trying to slow it down. So there are two forces, and then that is how they're trying to explain that's universe expansion of the universe, right? And there are some other terms related to expansion of the universe. One is the Hubble constant, which explains the expansion rate. It is the rate. It is the constant used to explain the expansion rate of the universe. And there is something called Hubble tension, right? So all of these are described by Edwin Hubble, right? And Hubble tension, just to be very simple, and I'm trying to make it as simple as it can be, because otherwise these are extremely scientific things, extremely technical, right? So Hubble tension is just that when you're trying to measure expansion rates using two different methods which are completely logical, and still you get a different answer in the end, right? So that is what is the Hubble tension, the meaning of Hubble tension. It is the conflicting expansion rate measurements that you get from two different completely logical theories, right? Um, so that is the understanding. Okay, and then the methods for all this, there is one thing called CMB analysis, again, cosmic microwave background radiation. You analyze that, and then you try and calculate what is the expansion rate. And another is cosmic distance ladder. Now, if you heard of terms called redshift and blue shift, if something is moving away from, no, this is very similar to if you have heard something called Doppler effect, which is related to frequency. So if what happens is that objects, if you're standing here in space, and if an object is moving away from you, it will show a red shift, and it is moving towards you. It will move towards the blue side of the spectrum. If you remember, there's a spectrum, and in the spectrum, let me break it over here. There's a spectrum, and in the spectrum, there is visible light. One side there is red, one side there is blue, right? So because of different frequencies, they detect different frequencies when objects are moving away, right? They are going to um, show different frequencies, like the waves are going to become longer. I hope I'm able to make sense of this. I mean, it's something that I've explained in my previous videos, so I'm not spending a lot of time here. But I hope I am able to make my point clear that when an object is moving away, it is going to be showing a different frequency. When it's moving towards you, it's going to be showing a different frequency. So that is why there's going to be either a shift towards the red side of the spectrum or the blue side of the spectrum, right? And that is also one of the ways in which you understand the expansion of the universe, right? So that is all about universe and what is the meaning of expansion of the universe, right? Let's move on to the next one, which is planetary defense. Now, ISRO is planning to study Apophis. Now, if you know about Apophis, it was something uh, that was considered a near Earth object and a threat to Earth, because there was speculation that it might come and collide with Earth and it can cause damage, right? But now it's no more considered to be a threat. It's just an asteroid, right? So it was discovered in 2004, initially considered a major threat. It is of no risk right now, at least for a century. So ISRO is planning to study this asteroid in 2029 when it comes very close to Earth. Right, so it is part of the planetary defense efforts to understand whether, if an asteroid comes this close, what to do. All right, so that is one thing about planetary defense. Okay. Uh, now, what is the meaning of planetary defense? What you're trying to do is you're trying to detect, track, assess, and deflect near Earth objects, or NEOs. Right, so first, what you want to do is you want to detect them from far away. You want to track their movement, whether they are coming close to Earth or not. You want to assess what kind of impact are they going to make, and then you want to deflect them to a different direction so that they do not come and collide with Earth. In fact, that was the objective of OSIRIS APEX mission of NASA. This was going to study Apophis. Again, they were going to do something very similar. They were trying to study how to deflect Apophis, which was considered a threat. Right. NASA has another planetary defense mission called as Double Asteroid Redirection Test. Again, something sort of a weapon, right? To try and deflect it. Uh, if an asteroid is moving in this particular direction, maybe you'll try and uh, you know shoot something so that it deflects in a different direction. Maybe even a slight deflection is enough in space to put it out of any major collision with Earth. Right. So that is the understanding. That is what they are trying to achieve. Right. Then there is a similar mission, Rapid Apophis mission for space safety. This is by European Space Agency. Then there is an international collaboration for warning of asteroids. I mean, all these are planetary defense efforts, right, of various organizations. So I've told you about NASA, I've told you about ESA. There's an international collaboration for asteroid warnings, right? So that is called as International Asteroid Warning Network. Then there is a Neo Coordination Center also. Then there is India. If you talk about ISRO, there are two missions. One is Project Netra, which is going to be an early warning system for space debris, and then near Earth objects. It usually tries to detect and track all these objects which are going to be of threat to Indian satellites. And there is a mission Shakti, which was an anti-satellite test, which was conducted a few years ago to demonstrate that. It was conducted actually in 2019 to demonstrate that India also has this kind of security system. It has this weapon of um, neutralizing a satellite in outer space. All right, so that is the understanding of planetary defense. I hope we have understood what is the meaning of planetary defense, what are different missions going on from different agencies, why was it in news, and what is asteroid Apophis. Right, so that is what it is about. Let's come to the next one, which is Van Allen radiation belts. Uh, Now there was a mission, Polaris Dawn mission. It is the world's first private spacewalk mission, which was recently successful. Right, so this was a first private successfully conducted spacewalk. Right, so the astronauts, they traveled through high radiation regions. Okay, they traveled through high radiation regions, which is Van Allen belt. Right, South Atlantic is also just one term related to Van Allen belts. Now, if you look at this, this is all how the Van Allen belts look like. So the Earth has a magnetosphere around it, right? So it has magnetic fields, and then it creates a magnetosphere. All right, this magnetosphere is protecting Earth from any kind of magnetic storms, which can come from the sun or from other sources. These magnetic storms can cause power grid failures. They can cause uh, your satellites to not work. So the GPS could be down. So a lot of different issues could come up as a result of magnetic storms. So when your magnetosphere rise to protect you, right? So uh, uh, there are uh, there are basically, if you talk about Van Allen belts in this magnetosphere, there are two layers. So the inner layer, there's an inner layer and there's an outer layer. Now, I mean, if you look at it, the more they have understood, they said that okay, over time it could be just one layer, could be, I don't know, the shape could be different. It could be very flat. It could be not so flat. It could be a lot of things, right? So, but basic understanding is that there are two layers, inner layer, outer layer, right? Um, Okay, so the outer layer is made up of high energy particles coming from outer space, right? And the inner layer is just interaction of cosmic rays with Earth's atmosphere, right? So that is the inner layer, and the outer layer is just high energy particles coming from the sun. Okay, so this is what Van Allen belt is. Now, astronauts need to pass through this belt. Usually, they are able to pass through it easily because they might not come in contact with it, or the shape might be very different, so they will be able to escape it, or they pass through it very quickly for a short span of time, so they are unaffected. On mostly the spacecraft has a protection, so the covering is there. That way, they are protected, right? So that is why it was there in news, because they passed through this high radiation region. And one of the terms that is related to this is South Atlantic anomaly, which is the region where the inner belt comes very close to South Atlantic region. Inner belt comes very close to South Atlantic region. So then what happens is that this region becomes highly ionizing, the radiations. So that is why sometimes you want to study the South Atlantic anomaly, when it becomes highly ionizing over there. Okay, so that is the meaning of Allen belts and South Atlantic anomaly, and why was it in news, right? So that's all about this. Then let's look at another thing which was in news last year. Now, not as much important, but you should know what is a super blue moon. It is a rare event which occurs every 10 years or so, and it is a combination of super moon and a blue moon. So what is a super moon? It is when the moon is full and closest to Earth, which is the position is called perigee, and blue moon you can look at when the blue moon happens. So yes, you might have heard of the phrase once in a blue moon. So it is something similar. But a super blue moon is even rare, which is a combination when a super moon and a blue moon, they happen at one time. Okay, so that is the understanding of this super moon, super blue moon. Right, let's move forward. Now, Axiom missions, Indian astronauts selected for Axiom missions have completed initial training. So now this is again a private astronaut mission. Uh, Again, a private astronaut mission. Now, this Axiom Space Agency, they are also trying to make their own space station in the future. It is going to be the first commercial space station in the world. Right. So Indian astronauts, they were part of this mission and they have completed initial trainings for this mission. Right. Um, so Axiom 4 is the fourth private astronaut mission to the International Space Station. It was launched on a SpaceX Falcon 9 rocket with a Dragon spacecraft, and it was jointly coordinated by NASA and Axiom Space. Axiom Space is the private US agency which is behind this mission. The mission timeline is there in front of you. AX1 is first all private mission to the ISS. AX4 continues to be uh, continuously commercial spaceflight advancements. Right. So this is all about Axiom missions. Again, something that you need to keep a track on. Then we come to dark comets. Now, dark comets are, uh, they are asteroids. They look like asteroids, but they behave like comets. What do I mean by that? I mean, they are just asteroids which are releasing gas and dust as and when they're moving. So they're moving very fast, and they're moving like a comet. Uh, they'll come very close to sun, right? They'll approach the sun, and then they will move to the farthest reaches of the solar system, right? So they have elongated elliptical orbits just like comets, and sometimes they will deviate from the expected orbits, which is not completely understood why they do that. But they spin rapidly and this disperse gas and dust in all directions, which makes them very hard to detect. Now, because they are dispersing gas and dust in all directions, they look like comets, because comets also do the same thing, right? They are dispersing gas and dust as they're moving through the space in the solar system, right? What are dark comets? They are something that look like asteroids, but they behave like comets. They have less surface area for material to form visible trails. So their trails, they are not visible like the comets you see there is visible, but for a dark comet, it is usually not visible. So that is why it is called as a dark comet. And Oumuamua, this was no, this was something that was in news a few years ago, and this was found to be a dark comet. Now they have identified around 14 such objects in space which behave like dark comets. Okay,